everybody. This week we will have 3 short videos for you, so we're doing things a little bit differently instead of one long video. So you can break up however you want to learn each topic, however you want to learn it. So here are the 3 videos that you will be watching. This one will be about surface area and volumes of cylinders. The next video should be, or the one that I recommend that you watch second, should be surface area and volume of prisms. That'll be with Mr. Strickland. And then the third video will be Cavalieri's principle with Mr. Florence. So to get us started with surface area and volume, I'm going to be talking about a can of chickpeas. And so since I am talking, or garbanzo beans, chickpeas, whatever. So since we were talking about surface area and volume of cylinders, this is a cylinder. This is what we're going to be working with in this video. Mr. Strickland will extend this concept to general prisms, and then Mr. Florence will extend the concepts a little bit more. So let's jump right in. If I'm thinking about surface area, I'll start with surface area. I'm thinking about the entire surface of this can that I can touch. So the area of all of this space that I'm touching, really. So if we think about the area, I've got the sides of the can that I can hold. So that is called the lateral surface area, so the sides of the can. And then I've got the bases. So I've got the top and the bottom. You'll notice that Mr. Strickland will talk about what it means to be a prism. But this one we could consider like a circular prism because the top and the bottom, both bases are exactly the same. So this is a right prism. It goes up and down at a right angle. And the two faces are the same. So let's break this down in terms of surface area. So if I think about surface area, I'm going to think about the side that I'm touching. So the label of this can. If I were to peel off the label, we've got a bare can here. This label looks an awful lot like a rectangle. And so that'll lead us to the next slide that I've got here. We've got the rectangle. So this is the surface or the lateral surface that I was able to touch on the can. So it's easier to calculate the area if I think about it in terms of a 2-dimensional object instead of a 3-dimensional object like this. So peeling off the label makes it easy for me to see that I've got a rectangle, I've got a length, and I've got a width that I can work with. I went ahead and I measured this already, so I'll put the measurements up in a second. But this isn't the entire surface area of the can yet. This was just the lateral surface area. So if I think about the top and the bottom, those two shapes are circular. So I have a top and a bottom circular shape. So if you look at the screen now, we've got all of our surface of our can. We've got the lateral surface area plus the area of the two bases. So now we have to go into the actual calculations. How much area is this? So when I went through and I measured the label, I measured the width of this rectangle. I guess I could do it this way. I measured the width of the rectangle, and that was 4.5 inches. So looking at this label, I know that the height or the width of this is 4.5 inches. When I think about the length of this, rather than measuring it with a ruler, what I wanted to really emphasize is the fact that this label went all the way around my can, right? And so there's a special name for that distance around a circle. That's the circumference. So I'm going to calculate the length of this entire label, or the length of my rectangle, as really being the circumference of this circle, because it does wrap completely around the circle itself. So rather than measuring it and getting an approximation, I'm going to incorporate pi into this because of the circumference to get a more accurate answer. So to do this, when I think back on circumference, we had said that circumference was 2 pi r, which means that I need my radius. So what I did is I looked at this can, I looked at the circle, and I measured directly across with my ruler, which is over here. It's broken, but I measured directly across the widest part of my circle. And so what I ended up with for the diameter, since I measured all the way across, was 3 inches. So that gets me started here. So if I know that 3 inches is my diameter, then I know that the radius is really just half of that. So what I'm going to do here is say, diameter is equal to 3 inches, which means the radius is 1.5 inches. So when I'm thinking about this entire label length from one end all the way to the other, it's really my circumference. So 2 pi times my radius, 1.5 inches. Or we could think of it, if I multiplied the 2 and the 1.5, really the length of this rectangle is 3 pi inches, right? So we're going to stick with that for now until I calculate all of the entire area. So over here to the right, I'm going to say that the area of label, and really the area of the label is the lateral surface area, is really the area of this rectangle. So it should be length times width. And so with that being said, length times width, in our case, the length was 3 pi inches, and then the width was 4.5 inches. So I'm going to put these into my calculator. I'm going to get us an approximation here. 3 times pi. I should have done this ahead of time, but it is what it is. So getting an approximation, notice I'm doing inches times inches, so I have square inches now. 3 times pi times 4.5 gives me 42.4. So I'm going to say 42.4 inches squared. That's my lateral surface area. So we'll just abbreviate that for now. But that's not my entire surface area. That was really only this space in here. So what I want to do now is calculate the area of the top and the bottom. Remember that we've already done this in a previous video. So our area of our circle was pi r squared, and we've already calculated our radius. So I'm going to say area of both bases. I'm just going to calculate both of them at the same time. Is going to equal this pi r squared, and in this case my radius again was 1.5. Pi r squared, and that would be for one of them, so that'd be one surface area, but if I want to do the other one as well, I'm going to multiply this number by 2, because I've got 2 of those circles. So now let me put that into my calculator. We've got pi times 1.5 squared times 2. That'll give me about 14.1. So 14.1, again, we're talking about inches squared because this was inches that I squared, right? So area of both bases, so we'll say bases area, you can barely fit that, sorry, is 14.1 inches squared. So if I think about let me move this down a little bit. So if I think about the total surface area, I don't know why there's a T here. I would just add both of those together. So we'll say total surface area is equal to the 14.1 inches squared plus the 42.4 inches squared. And then let me get that for us. So we've got total surface area is equal to 56.55. I'm going to round it to. And so I don't know if you can see too easily on the calculator, but that's how I got my calculations there. So I used the rounded numbers, or I used the exact numbers, so that way I could get a more accurate answer. So 56.55, again, inches squared is what we're talking about here. So that would be my total surface area for my can. Now if I'm thinking about volume, I have to think about all of the square inches, or sorry, all of the cubic inches I can fit inside of this can. And so to do that, I want to kind of take this can apart a little bit. And so I'm going to take this lid off, dump out my chickpeas into, I got a bowl handy, so I have plans for these chickpeas later. So now that I've taken this lid off, kind of, let's see here. Careful if you do this at home because these cans are sharp. So now that I took this apart, I can see that this was the circle that we already calculated the area for. If I think about the volume, I can think about the fact that this circle or this area really fits through my entire cylinder. So if I were to put this through, notice that it falls all the way to the bottom, right? So that means that this whole shape is really circular, this exact circle, all the way through the entire can. So we're going to use that to help us calculate volume pretty quickly. I'm already at 12 minutes, so I want to rush through this a little bit here. So now we're shifting. Notice the title of this is Volume of Cylinders. So we already know from the previous slide that the area of the base, and actually I shouldn't have done them both at the same time, but let me go through here. So the area of the base goes through the entire can, which means that if I did the pi r squared, that pi r squared area goes all the way through the entire height of my can. And we had said that the height of the can was equal to really the height of the label that I had taken off of it, right? So now all I have to do is take this area of the circular part, so the area of the lid, and I'm going to take that and multiply it by the entire height since it fits all the way through the can. So the height of the can here is the 4.5 inches. So we'll say the pi, my radius we said was 1.5 inches squared times the 4.5 inches. And this is the volume. So now I'm going to take my calculator, multiply all of those together. So I've got pi times 1.5 squared times 4.5. And so now I've got, for my volume, I've got 31.808. Let me show you that, 31.808. So I'm going to put 31.81. Notice that I have inches squared here, and then I'm multiplying by another inches, so that leaves me with cubic inches. So my entire volume here would be 31.81 cubic inches. So hopefully that made some sense. I tried to keep the numbers nice and simple for you. Again, let one of your teachers know if something I said was confusing to you. You'll get an opportunity to practice this in a real-life application with this week's assignment. And as always, just show up to office hours if you have any questions. Have a great week. See you next time.